Good afternoon, everybody. Welcome to another exciting afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. I hope you all had a nice 4th of July holiday weekend. Uh, Friday, I got a big weight off my shoulders. Uh, I had this company come out, tree trimmers. They cut down a couple small trees that I should have gotten, but they got too big. And then I did some tree trimming. In fact, one tree in front, big one in front of my house, had a huge, about this diameter, about 15-foot dead branch that I knew I had to take care of, and I couldn't do it myself. And the bad thing was, it was near my neighbor's house. So if they messed it up, they would have wiped out their house big time. They didn't. These guys were really professional, really good, and competitive with other services I got quotes from, but these guys are really professional, top notch. If anybody ever needs tree trimming, email me. I'll give you their name and contact information. All right, we got a lot to do and enough time to do it. Let me remind you, on Thursday, I will be giving test number 2. Hold on one sec. All right, thumbs up, people. Do you see test number 2 information on your screen? Thank you. All right, and I've mentioned this last week, but I think I should go over it again. I'll be giving test number 2, the PDF file you should see tomorrow afternoon on wrong school, D2L. And on Thursday, right after class, about 10 after 4, I'll send out an email to each of you individually with the password, and you'll have until Friday morning, 10 a.m., to upload your test number 2 to the assignment area D2L. It should take you about 40 minutes, 40, 50 minutes. If you want to take an hour, even if you go an hour and 10, that's okay. It's one of those things, you either know it or you don't. It has 9 pages, 10 problems. Some of the problems are multiple part. I will never in Chem 170 use multiple choice. Never have, never will. Covers alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. Here are the point breakdown: 11 points general knowledge, 34 points nomenclature, and 60 points reactions. Turns out there are 4, yes, 4 synthesis problems on there. It's not an open test. We'll have our regular Zoom meeting and lab. I should take the lab out. I made a mistake there. Uh, Regular Zoom meeting on Thursday. Oops. Anyways, that's test number 2 coming up this Thursday. And because of that, today's game plan is first, I'm going to do my world famous review for next test, test number 2. Then I'll go through the aldehydes and ketones problem set, and then we'll go back to carboxylic acids and continue on with there. Remember always, there's no such thing as a dumb question in my class. Always feel free to ask questions, and do not worry. Oh, what if we're going to throw Dr. White's schedule off track because I'm asking questions about this or that? No, that's my problem to deal with, which is really not a problem because I have extra time snuck in to allow for people to ask questions. So always feel free to ask questions. Any questions? All right, let's get into the review. That's my thumbs up, people. You see test 2 review. Thank you. All right, let's start out. Alcohols, ROH, hydroxyl group on a carbon. Remember, always look for what's different in a molecule, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, should get your attention like that. Hold on, like that. And it should. Oops, that was off. Can you keep a secret? For test 2, look for oxygen. For test 2, look for oxygen. Shh. Now, alcohols, how do you name them? You find the longest chain or ring with the carbon with the hydroxyl group, hydroxyl OH, drop the E at the name of the alkane or cycloalkane and add OL. For acyclic, you need a number. For ring, no number, because that carbon is going to be number 1, and the rest of the alkyl groups you know how to do. Remember, in an acyclic, that's always going to be given the lowest number. Now, IUPAC and common name, benzene ring hydroxyl group, phenol. Now, we're getting to the good stuff. And what's a common name for alcohols? For smaller alcohols, name the R group on that OH is attached to. As an alkyl group it is, and then at the end add the word alcohol. And remember, rubbing alcohol is 70% isopropyl alcohol, which is 2-propanol, and 30% water. And if you go to big box stores like Walmart or Target, or as my friend calls it, that French store, Target. But anyways, you can find rubbing alcohol where this number is up to 90%, and this is 10%. All right, how do you make an alcohol? You take a double bond, react it with acid and water. Remember, water is HOH. You break the pi bond, one carbon gets H, the other gets OH, and it follows Markovnikov's rule. The carbon of the double bond with the most hydrogens gets the hydrogen from water, the other carbon gets the hydroxyl. And by the way, I believe this is the only reaction from test 1 or any test, well, you only had one, that I'll have on here. I don't do previous test questions on new tests, but I talked about this in the chapter in alcohols, so it's fair game. Well, that reminds me. The best way to study for the test is 1, go over this review, and 2, do the practice problem sets. As with test 1, with test 2, and all my tests and final, every question I asked, I've gone over a concept behind that question at least twice, usually a lot more. All right, now, how do you react an alcohol? Well, if you take an alcohol and react it with acid and heat, H2SO4, sulfuric acid. Now, a lot of times I don't put the number 180, that just tells you got to really heat it up, and you do. I've run this reaction. And what happens is you lose water, hydroxyl group on one carbon, and a carbon bonds to that carbon with the hydroxyl group with a hydrogen. And between those two carbons, you form a double bond. Now, remember Zayseth's rule. Zayseth's rule is you get the alkene, the double bond product that has, if you have a choice between two in a molecule, that has the most carbon atoms, not total carbons, but carbon atoms directly bonded to the carbons of the double bond. And I think this is something I should do, which I don't usually do during a review, is the following. Everybody see my whiteboard? I just wrote the equation on the whiteboard. Thank you. Your turn. Give the organic product or products for the following reaction. Don't forget Zay's rule, then I'll do it. I see one person's done. When you're done, give me a thumbs up because all of you got your video off. Does guilt work? No, it didn't. All right, I think everybody's done. Let's take a look at this. What's different? Oh, hydroxyl group on a carbon and adjacent carbons with hydrogen. And this is dehydration, meaning you lose water. And it follows Zay's rule. Now, if we look at the molecule here, here's the carbon with the hydroxyl group, and we have two adjacent carbons with hydrogens, A and B. And if I lose the hydrogen from A and the hydroxyl group, between these two carbons, I'll form a double bond. And that's right here. Now, if I lose the hydrogen from B and the hydroxyl group here, I will form this compound. Now, Zay's rule, you find how many carbon atoms are directly bonded to the carbons of the double bond. These carbons. And the answer is 1, 2, 3. This you don't count. If we go to B, how many carbon atoms are directly bonded to the carbons of the double bond? And the answer is here. And notice we have 3 circles here, or carbons, and 1 circle here. And Zay's rule says you get the one with the higher number, which is this. Therefore, this is your answer. And that's how you do it. All right, let's move on. If you take an alcohol, we did that one, and react it with HX, where X can be chlorine, bromine, or iodine, you replace the hydroxyl group with the halogen on the carbon the hydroxyl group was on. Again, if you react an alcohol with HX, where X is chlorine, bromine, or iodine, you replace the hydroxyl group on the carbon with the halogen that the carbon originally had the hydroxyl group. Now, because this could react with double bonds, someone, I have no idea who came up with this, if you take an alcohol and react, this is called thionyl chloride, SOCl2, you replace the hydroxyl group now with a chlorine on the carbon that the hydroxyl group was on, but This will not react with carbon-carbon double bonds. So that's why you like to use it in certain cases. Next, if you take a primary alcohol and oxidize it, you will get an aldehyde. Remove this hydrogen, this hydrogen. Bracket O bracket means oxidized. And thank you, Dr. White, because you don't have to learn oxidation reagents like potassium permanganate, sodium dichromate, potassium dichromate. I'm just asking you to learn the general symbol. If you take a secondary alcohol, same thing happens. Hydrogen, hydrogen form a carbon-oxygen double bond, as you learn later on, carbonyl, and you make a ketone. Now, if you look there, you'll see, guess what? There's no tertiary alcohol. I will never put the reaction, excuse me, what you get when you react the tertiary alcohol with an oxidation reagent, O bracket, bracket O bracket, because the answer is no reaction. And I will never put on a test or final in Chem 170 or any course I teach where they ask you what's the product or products and you write down no reaction. That's not fair. I teach by my golden rule of teaching. I didn't like it when I was a student. Why should I do that to you? I don't. Wrong one. Right one. All right, next we talked about thiols. Thiols is the sulfur analog of an alcohol. Instead of a ROH, you have RSH. And the important thing, two things you should know, excuse me, about a thiol is one, they stink. Ooh, they stink. And thiols are put in natural gas. The actual thiol is T-butyl thiol. That's a common name, not an IUPAC name. But you should know a thiol is put in natural gas because they had horrific tragedy in Texas in I think it was 36 or 37, that killed a lot of students and teachers in a town in Texas. And they put a thiol in the natural gas. So if you have a gas leak, you can smell it. You should know that. Next, I like that, talked about ethers, ROR prime, oxygen with 2 carbon groups on it. And I didn't ask you to learn the IUPAC nomenclature, but I did ask you to be familiar with the common name. And the common name is name each R group as an alkyl group. At the end, add the word ether. There's only one reaction I asked you to learn, and that was the Williamson ether synthesis, named after the chemist Williamson. And take an alkoxide, RO minus Na plus, reacted with R prime X. I don't have here, but X can be chlorine, bromine, or iodine. And this oxygen attacks the carbon with the halogen to form an oxygen carbon bond, and you lose sodium plus X minus, and you make a salt. Now, if I'm asking you, give the reaction product or products, you don't have to put down the salt, but if you're trying to figure out the starting materials, which is in the problem set, then I will give you the salt. One thing I should mention, if you're supposed to get 2 products or you start with 2 reactants, I will put a plus sign where you're going to put the answers so you know you have to put down 2 things. That's my special gift to you. When I was a student, our instructor didn't do that. All right, next we talked about epoxides, but really one special epoxide, ethylene oxide. You do not have to know the name of ethylene oxide, but you do have to know the following 2 reactions. If you take an alcohol and react it with 1 molecule or mole of ethylene oxide, you get this this ether alcohol. Getting ahead of myself. 1 molecule of alcohol, 1 molecule of ethylene oxide, you get this ether alcohol. Now, if you use more than one N molecules or moles ethylene oxide with one molecule of an alcohol, you get this polyether alcohol. And notice N is over here, and that's how many times OCH2, CH2 is repeated. Remember, the hydroxyl group is never inside the bracket for this reaction, or it's wrong. I'll mark it wrong, so please don't. All right, next we start talking about aldehydes and ketones. And an aldehyde is a carbon double bond to oxygen with an H and an R group on it. A ketone is a carbon double bond to oxygen with two R groups attached to the carbon double bond to oxygen. Now, aldehydes. Find the longest chain with the carbon double bond to oxygen. Let's see, I have it down here further. Remember, and I'll get this again, you should know what is the carbonyl group and how to describe it with words. Carbonyl group is carbon double bond to oxygen. I won't ask on a test, but I used it in the terminology when I taught you this. The carbon double bond to the oxygen is called the carbonyl carbon. So for aldehydes, find the longest chain that has the carbonyl carbon, carbon double bond to oxygen in it. Name it as an alkane. Drop the E, add Al. No numbers needed, because the carbonyl carbon as an aldehyde is always number one. Everybody knows that. Now you do too. Important public service announcement from Dr. White, and that is alcohols have an OL ending. And let's see if I can do an A. Sort of. But anyways, aldehydes have AL. When you're writing on a test nomenclature, the names, make sure your O and A are clear. You don't want me guessing, is that an A or an O? Because I have a 50% chance of saying, no, you're wrong. So you don't want me guessing. Make sure on test number 2, when you're writing nomenclature for aldehydes and alcohols, make sure the OL for alcohols and the AL for aldehydes is clear. And remember, you can't have an aldehyde in a ring, so we don't have to worry about that. Now, the common name was made the IUPAC name, and you should know when R is a benzene ring and is an aldehyde, they call that benzaldehyde. That's both the common and IUPAC. Now, for ketone, carbonyl bonded to oxygen with two carbon groups attached to it. Find the longest chain or ring, alkane or cycloalkane, name it, drop the E and add ONE. For acyclic, you need a number. Which carbon is the carbonyl carbon, and that should have the lowest number closest to the end of the chain. Drop the E, add ONE. For acyclic, you need a number. That's which carbon is the carbonyl carbon, and that number should be always the lowest closest to the end of the chain. Now, for ring, cyclic, no number, because the carbonyl carbon rocks, and it's always number one. I know of no exception. And Dr. White's an expert in cyclic ketones. Oh, I love them. I do. Now, I asked you to learn 2 common names. And for common names like ethers, I think I mentioned, if not, I'll mention it now. I will never ask you what's the common name for the structure, but what I will ask you is, here's the name, draw the structure. Why? Because you'll see common names on ingredients labels. And what do we have? The simplest aldehyde, turns out R can be H, is formaldehyde right here. The simplest ketone, when R prime and R are methyl groups, is right here, acetone. Again, formaldehyde and acetone. And if you remember, and this won't be on the test, I talked about the dangers of formaldehyde when not used properly. On my last patent, I used formaldehyde, but it was used, the company I work for, properly and safely. Chinese, well, anyways, I talked about dangers that have occurred in wood. All right, back again. You should know carbonyl group, how to draw it. Carbon double bond to oxygen, 2 lines means it's bonded to something else. And the carbonyl group, you should know how to describe with words. Carbon, or you could also put down carbon atom, carbon double bond to oxygen, or you could also put down oxygen atom, but really simplest way, carbon double bond to oxygen. Now, how do you make ketones and aldehydes? Oh, deja vu. Or as Yogi Berra used to say, deja vu all over again. You haven't heard some of the great phrases from Yogi Berra, who's a great baseball player and a manager. You should look him up on the internet. He has some doozies. All right. Well, that's my favorite one, deja vu all over. It's deja vu all over again. But anyways, take a primary alcohol, oxidize it. We did this to get an aldehyde. Secondary alcohol, oxidize it. You get a ketone. Now, there's a special reaction. That's Friedel-Crafts Isolation. This is where you make a carbon-carbon single bond. And you react a benzene ring with an acyl group, or acid chloride, in the presence of aluminum trichloride. And the carbonyl in the R group is bonded to the benzene ring. You also get HCl, but I'm not worried about inorganic stuff. And this is a way of making aromatic ketones. And that's how you make ketones. Now, let's react ketones and aldehydes. You notice the first reaction here, and I did this throughout, where you have a ketone or aldehyde when R prime is H, is say aldehyde when R prime is carbon, is a ketone. Alcohol and acid, keep your eye on the carbonyl carbon, what's attached to it, R prime or H and R double prime are still attached to it. This opens up the OH group, and OR, the OR comes from the alcohol. That's 1 molecule or mole of alcohol. Now, the next one is 2 moles or molecules of alcohol. And here we have, again, keep your eye on the carbonyl carbon, what's attached to it. If R prime is H, it's an aldehyde, it's carbon's a ketone. And here, what's attached to is still there. And now you get on that same carbon 2 oxygens on each argon. Oxygen is the R group from the alcohol. Now, I talked about my boss, my PhD advisor's advisor, Gilbert Stork, came up with a way of protecting aldehydes and ketones by reacting aldehyde and ketone using ethylene glycol, that's this, plus acid. Think of this as 2 molecules of alcohol in the same molecule. And this is the product you get, but for some reason, students forget to put in the bond between CH2 and CH2, and Dr. White marks it wrong. Now, once you get a hemiacetal or hemiketal, acid and water, or I can put down H2O/H+, whenever you have 2 oxygens single bond to the same carbon, you're going to get the same reaction products. And that is, this breaks down the hemiacetal or hemiketal to the aldehyde or ketone you would have used to make that molecule. Keep your eye on the carbon with 2 oxygens becomes this carbon, and the R group on this oxygen becomes this alcohol. The hydroxyl group is on the carbon this oxygen was attached to. And if you take and react now an acetal or ketal, by the way, it fell off, next to R prime should be bracket H, closed bracket, like right up here. But again, this is the only two places, this reaction and the one before it I just did, when you have two oxygens single bonded to the same carbon, you get the same products, acid and water. You get back the ketone or aldehyde you would have used to make, in this case, the acetal or ketal, plus the alcohol. Now, I tried to make it smaller, meaning you don't have to put it in there, but those of you who feel, how should I say, bothered by not balancing things, organic chemists do not, you can put the two there. You don't have to. All right, next, some fun time. Take an alkyl halide, RX. X can be chlorine, bromine, or iodine. Reacted with magnesium, you make the Grignard reagent. If you put down RXMG, I'll mark it wrong. It's RMGX. The MGX is on the carbon that the halogen originally was. And now, what do you do at Grignard? You make carbon-carbon single bonds. If you take an aldehyde or ketone, react to Grignard, second step, the oxygen fell off. That should be H2O. Reacted with acid and water, not hydrogen. You'll get this alcohol. What's attached to the carbon, R prime or H, and R double prime is still there. And then you'll have a hydroxyl group. And now the important thing, this R triple prime from the Grignard is bonded directly to the carbon that was the carbonyl carbon. And for your fun and enjoyment on this hot Tuesday afternoon, what would be the product or organic product or products for the following reaction? 3 points each. I see one person's done. Don't forget, give me a thumbs up when you're done. Can you imagine how dangerous it would be if you could create your own emoji hand signals in Zoom? No. I tell you, I have a Star Trek mind. My mind goes where no other minds have gone before sometimes. All right, everybody done? Oh, you know what I haven't done? Not that. This. All right, I think everybody's done. Let's look what's different. Ooh, oxygen, carbon, carbonyl, hydrogen, but it could be R prime, and carbons here are double prime, aldehyde or ketone. In this case, it's an aldehyde. I'll call that R prime, that R double prime. Remember, keep your eye on the carbonyl carbon. That's where the fun is. Let's see, carbon, ooh, magnesium chloride. This is a Grignard. Second step, acid and water. Remember, X can be chlorine, which it is, bromine, or iodine. And what do you get? Carbon, that was the carbonyl carbon. What's attached to it, R prime or hydrogen. R double prime is still attached. This opens up an alcohol. Then you make that special rare thing. This R group attacks and bonds to the carbonyl carbon. And you've made that carbon-carbon single bond. Notice no oxygen there. People get confused with the hemiacetal, hemiketal, and throw an oxygen there and mark it wrong because it is. So carbon, this one. What's attached to it? R prime is hydrogen. R double prime, methyl. Hydroxyl group, what's our triple prime? Right here. 2 carbons. And there you go. And it's time for another public service announcement from me. And that is, don't forget, on test 2, your friends are, how many bonds to carbon? 4. Make sure when you write down the answers, if you have 5 bonds to carbon or 3, you're going to be wrong. There's always 4 bonds to carbon. The other thing is, do you break carbon-carbon single bonds? No. I'll say that again in slow motion. Do you break carbon-carbon single bonds? No. That was pretty good. You don't. Those are your 2 friends on test 2. Same thing on 3, 4, and the final. But remember that when you're taking test number 2. Now, carbonyl, carbon double bond to oxygen. So pi bond is sigma bond. If you add a hydrogen and a catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon of the carbon-oxygen double bond gets a hydrogen. And this is another way of making alcohols, which I didn't want to cover earlier because you didn't know what ketones and aldehydes were yet. Now you do. And that's one way of making an alcohol. Now, since this could react with a double bond carbon-carbon when you don't want to, H.C. Brown, Dr. Brown of Purdue, came up with 2 new reagents. I'm only teaching one, LiAlH4, lithium luminidride. Think of this as a Grignard where R triple prime is H minus. And it attacks the carbonyl. And it's just like hydrogenation, but lithium aluminum hydride will not react with a double bond, carbon-carbon double bond, where hydrogen and catalyst will. I'll never put that on a test in this class, but it's good to know. And you should know how to do these as synthesis. That reminds me. All right. This reaction right here, aldehyde or ketone, alcohol and acid to make a hemiacetal, hemiketal. The next one, reacting an aldehyde or ketone with two molecules of an alcohol or acid to make an acetal or ketal. Then the next after that, including a special case as part of this one, number 3, hemiacetal, hemiketal, acid and water reaction. And this one, number 4, acetal or ketal with acid and water. Those 4 reactions I will never put on test 2 or the final as a synthesis problem. I'll never do those 4 reactions as synthesis, but you should know how to predict the product or products. And then this Grignard reaction of a ketone and aldehyde, first step Grignard, second step acid and water, that should be H2O. I will never put a synthesis problem with that on there. Everything else is fair game. And the last reaction is the Aldol condensation. Remember, the alpha carbon has acidic protons react with base and water. My gift to you is, for this reaction, which organic chemists would normally not do, but I'll do for you, notice I have 2 of the same molecule. Take a proton off there, it attacks the other carbonyl and forms a carbon-carbon single bond. And this opens up to an alcohol, and that's why this is called an aldol condensation. What was attached to this carbon of the second aldehyde, CH2R, is still attached. And it's a great way of making carbon-carbon single bonds. Very rare to do and very important. All right, any questions? That's good. Look at my speaker to see questions. No, I should look at the chat. All right, this would be a good time to take a break. Come back in 5 minutes at 1:50, and we will continue with Chem 170. I'll see you in 5. I'm going to go stretch. Oh no, I'm running late. I'm late. I'm late for a very important day. Do y'all remember where that came from? All right, let's get back to work. Time to start. All right, does everybody see the aldehyde and ketone problem set on your screen? Thank you. All right, remember, if you have any questions on these, ask. We got time. All right, first question. Remember, nomenclature will be on test number 2. Speaking of test number 2 and other things, I forgot to ask. Did any of you happen to think of ethanol, which is an alcohol, when you pass the gas station? They put up to 10% in our gasoline. Or did you happen to, over the holiday, have any vodka or happen to be in a store that sells vodka or other hard spirits that has ethanol in it? That's an alcohol too. Don't drink gasoline to get drunk. It'll kill you probably or get you very sick. Next, did you look at a bottle of rubbing alcohol and see it has isopropyl alcohol, which is an alcohol, also known as 2-propanol, but nobody uses that. They use the common name. Or did you happen to be in a big box store and look, or maybe you've got it in your home, nail polish remover. See, I forgot to polish my nails. Not really. But anyways, nail polish remover has acetone in it, which is a ketone. Did you think about that? Remember, organic chemistry is all around you, and it won't hurt for you to think about it. Speaking about nail polish, I just thought of something. Back when I was a little kid, men used to always in a barber shop, they had a manicurist, and if you wanted, they'd put a clear coat of nail polish on you. And men, like my grandfather, my father didn't do it, but my grandfather, I think my brother-in-law for a while did it, his father did, they would have a clear coat of nail polish. Why? I don't know, but I guess that was the fashion back then. All right, let's go through it. Give the IUPAC name for the following. Again, you have to identify what functional group you're dealing with. Carbonyl, hydrogen, carbons, aldehyde. Find the longest chain with the carbonyl carbon, name it as an alkane, butane, drop the E, add Al, butanal. Now, if it's here, B, it's a ketone, and 4 carbons, butane, but a ketone, drop the E, add ONE. Since this is acyclic, it's on carbon 2, 2-butanone. Ooh, it's a pretty molecule. C. Now, here's something students have trouble with. You have a carbonyl, and on each side of it, you have carbons. Carbons here, and that's the ketone. But R and R prime are connected together. How many carbons in the longest chain? No, it's a ring. 6 carbons, cyclohexane. Don't forget the cyclo for rings. Drop the ONE, replace it with. Carbonyl carbon of a ring is always 1. Excuse me, always 1. Therefore, you don't put a 1 there because everybody knows that. And then if that's 1, the other alkyl groups get the lowest numbers. And notice on carbon 3, methyl, carbon 4, isopropyl. Now I have 3-methyl 4 isopropyl. Since I'm not holding you to the alphabetical rule, you could have put down 4 isopropyl, 3 methyl. And here's some more examples. Let's do D, aldehyde, longest chain 7, heptane, drop the E, heptanal. And on carbon 3, remember the carbonyl carbon is 1. Carbon 3 and 5 are 2 methyl groups. 2 is dimethyl. And when you have a di, you need 2 numbers, try 3 numbers. 3,5 dimethyl. Here, F, we have a ketone. Carbonyl, carbons here and here. Longest chain is 9. Nonane, drop the E, add O-N-E, known and known. The carbonyl carbon is carbon 3. That's 3 on carbon 6 is isopropyl, 6-isopropyl, 3 known. Now, there's 2 types of nomenclature questions on my test. And one is, here's the name, draw, give the, here's the structure, give the IUPAC name. The other is, here's the name, give the structure. How do you do that? Always start at the right and move left. Start at the right and move left. Al ending, aldehyde, if that were E, hexane, 6 carbons, aldehyde. Now, as I mentioned, and I'll mention again, the instructor I had always drew us carbonyls or oxygen-containing compounds on the right. And guess what? I do too. Next one, 3-octanone, start at the right, O-N-E, ketone. Is for E-octane, 8 carbons. Where's the carbonyl? Carbon number 3, which is the oxygen bonded, double bond to that carbon. Acetone, you should know the common name is the structure. Formaldehyde, this structure. And here, 2-tert-butyl cyclopentanone, O-N-E ending, ketone. If that were E, cyclopentane, 5-membered carbon. I put the carbonyl up here. You could actually put it on any carbon, but all of you will probably do it there. And then on carbon 2 is the T-butyl group. You can draw this way or this way, and so on. All right, next, give the organic product or product for the following reaction. What do we have here? Carbon-carbon hydroxy group oxidized, alcohol, oxidized an aldehyde. Remember, do you break carbon-carbon single bonds? No, so I have 2 here. I'm not adding, so I'll end up with 2. And this hydrogen are lost, and you get a carbon-oxygen double bond aldehyde. Same thing happens like here, C, I'm sorry. You have a secondary alcohol, oxidized, you get a ketone. So everything else stays the same, and you get a carbon-oxygen double bond. Can I give you a lot more practice? All right, let's look at E. Remember, all these, unless I told you like those 5 I just mentioned earlier, these are all fair game for a synthesis problem. There's 4 on test number 2. Benzene. Oh, by the way, my software likes to, this is called left justified as opposed to CH3. It's the same thing. I missed it. Usually I catch it because it likes to do it even when I tell it don't. But anyways, benzene ring, acid chloride, our group on a carbonyl that also has a chlorine plus aluminum trichloride. We place one of the carbons with our carbonyl, and you get a aromatic ketone, where one of the groups is a benzene ring. In this case, R is methyl. And here, R is a benzene ring, you get benzophenone. And if we look at H, here we have carbonyl. Again, identify what's different. Look for oxygen. It's double bond to carbon. It's got a hydrogen R group on it. Could be also a ketone. Carbon-carbon hydroxyl group. Oh, alcohol. And over here, H plus acid. And keep your eye on the carbonyl carbon. What's attached to it, R prime and R double prime are still there. It opens up the hydroxyl group in OR. Notice H is here. Methyl group R prime is still attached. Opens up the hydroxyl group R and oxygen. What's R? Ethyl. And let's look at A. Here we're doing the same thing, but with a ketone. Keep your eye on the carbonyl carbon. What's attached to it, our prime and our double prime are still there. That opens up to a hydrox group O, and what's my R group from the alcohol? Methyl. Now, if we now look at B and C, what do we have here? A ketone. Down here we have an aldehyde. Reacting not one, look at the number two. And carbon-carbon hydroxyl group, oh, an alcohol, two of them, acid catalyst, and you get aldehyde or ketone, two molecules of an alcohol. What's attached to the carbonyl part, R prime or H, and our double prime still there. This opens up to two oxygens, each oxygen has the R group. Now, here's where students get confused. This carbon is this carbon here. Our prime and our double prime are connected together in a ring, so they'll still be connected to that carbon. Then two oxygens, and what's my R group? Isopropyl. Now, if you notice, I forgot to do something, so I'm going to do it right now. We'll give you a problem or two because I forgot to put it in there. Bad, Dr. White. And here's what I forgot. So let me give you a practice problem or two. And students hate rings, Dr. White and Mother Nature love rings. And why don't you try this one? Give the organic product or products for the following. And on a test, I would do this. So you know there are two things you got to put. And when you're done, give me a thumbs up. I had the screen minimized. Now I can see all your screens, at least your thumbs up and your names. Big hint there. See two people done. I'll wait a little while so everybody can finish. All right, anybody need more time? I guess not. What's different? Ooh, not one, but two oxygens to the same carbon. And what do we have? This. And one of them is the hydrox group, the other is OR. So I'll call this R. And notice I have carbons here and here. One of these I can call part of them R prime and the other R double prime, and they're connected together in the ring. So if we look up here, what's attached to the ring, R prime, or if it was a hydrogen, it's not, but if it were, is still attached to the carbon that now is double bond to oxygen, which means I can immediately do this, put my methyl group, and this carbon, which is this carbon, I will double bond to oxygen. Then I'll get this alcohol, and here's my R group. So that's how you do it. Oh, let's do one more. They're good for your grade. And here's one more for you. Enjoy. If you finish early, please be patient. I try and give everybody time to finish. All right, looks like everybody's done. I should get to work. Now, excuse me. Must have been all that junk food I had over the weekend. Hot 4th of July, we'll do that. But anyways, what's different? Ooh, one, no, two oxygens to the same carbon. And one of them has carbons on it. And on that same carbon, I have a hydrogen, but I could call it also R prime, and carbons are double prime. And acid and water. Keep your eye on the carbon with the two oxygens, single bond to it. That becomes carbon double bond to oxygen. What's to attach to it, R prime or H, and R double prime stays the same. And then here we get, and I should have put here, I apologize, On tests, I check to make sure if I did put stuff like this on, there's a plus side there. You get an alcohol. So this is my R prime, this is my R double prime, and the carbons on the oxygen here is R. So carbonyl, this carbon becomes this carbonyl, double bond oxygen, H, and 2 carbons. And then my R group here is this, a T-butyl group, meaning common name, T-butyl alcohol. And that's how you do that reaction. Now, next one is if you take this molecule in D, what's different? Carbon with 2 oxygens, but each one has an R group on it. You also have hydrogen and carbons on that same carbon. And it could have been R or H and R double prime. And then on each oxygen, we have R. Acid and catalyst, similar to the last one. I just showed you, not up here, but on the whiteboard. You get back the ketone or aldehyde you would have used to make that, plus the alcohol. And if we look at D, R prime is H, R double prime ethyl, attached to carbonyl. R on the OR becomes this alcohol methanol. And if we look at F, I've done the chemistry instructor's favorite trick on a test, put a big scary molecule. But if you don't know what you're looking, yeah, it's scary. If you look, ooh, what's different? 2 oxygens single bonded to the same carbon. Each one has carbons on it. And the carbon is bonded to has carbons here and here, which means it's this reaction right here. And the ring has that carbon, which will be double bond to carbon, oxygen, and you'll still have the isopropyl group because you break carbon, single bonds. No. And next, we have R is N-propyl, becomes N-propanol, or 1-propanol, N-propyl alcohol would be the common name. Next, take this molecule, react it with hydrogen, a catalyst. What's different? Carbon double bond to oxygen, carbons here and here. It's a ketone, it could have been an aldehyde. Hydrogen, a catalyst, I didn't write down here, but the catalyst can be nickel, platinum, or palladium. Break the pi bond, each atom gets a hydrogen of the carbon-oxygen double bond. Everything else stays the same, and you could write it either way. I would be able to interpret they're the same, and they are. Now, if we look at C, same reaction. This is a ketone. Break the pi bond, each atom gets a hydrogen, but on a ring you don't show it, you get this alcohol. Now, with D, you have lithium aluminum second step acid and water reacting with an aldehyde or ketone, and it does the same thing. A different mechanism, but I'm not teaching mechanisms this class, but you get the same product as hydrogenation, but this will not attack double bonds, carbon-carbon double bonds. And here you get this alcohol. And same thing here. All right. Ooh, I forgot another thing. Boy, I missed a few on here. Sorry. And let's look at the following. You take an alkyl halide, react it with magnesium, you'll make the Grignard reagent. Remember, I got to force myself to do this. Oh, I don't like doing this. This is wrong. There's no such thing in all of nature chemistry, carbon bond to halogen magnesium. It's this order, and make sure you don't mess it up. Your turn. Give the organic product or products for the following. I think everybody's done. Let's do this. What's different? Ooh, halogen on a carbon. Ooh, that's an awful looking arrow. Alkyl halide. Remember, X can be chlorine, bromine, or iodine. Plus the Grignard, I'm going to have step by magnesium, and I make the Grignard reagent. What's our isopropyl? The carbon with the halogen, this one, which is this one, will have magnesium, and the halogen is iodine. And I know there's 4 bonds to carbon, so I can put in my hydrogen. Oh, that was fun. I got to do another one. And there's another one to have fun with. Give the organic product or products for the following reaction. All right, I think everybody's done. Look for what's different, what's not carbon, what's not hydrogen. Ooh, a halogen on a carbon, alkyl halide. X equals chlorine, in this case, bromine, or iodine. Plus, ooh, this is different, magnesium metal. And what you get, oops, it's the wrong answer. What you get is the Grignard reagent. And what's my R group? Oh, this big scary thing, but you just know it's R. It's coming along for the ride. You break carbon-carbon, single bonds? No. So I'll still have my methyl. Hold on. It's time for some quality control. That's better. You still have this methyl, You still have this methyl. The carbon with the halogen will have this on it. And that's how you do it. Now, once you have it, you can react it with ketone or aldehyde. And if we look at I have a ketone, carbon, double bond to oxygen, carbons here, ketone. It could have been an aldehyde, Grignard, second step acid and water. And now you make that something special, a carbon-carbon single bond. Here's the carbonyl, what's attached to it, R prime or H, and our double prime, still there. Opens up to an alcohol. And here is my R triple prime that came from the Grignard. And here, this is a carbonyl carbon. What was on there, methyl and ethyl, still there. My Grignard R triple prime is methyl, and I'll put that on there, and that same carbon will have a hydroxyl group. And if we look at C, ketone, carbonyl with carbons here and here, Grignard reagent, second step acid and water. This attacks the carbonyl carbon and bonds to it, isopropyl, and the same carbon, you have a hydroxyl group. All right, last one is a aldol condensation. And my gift to you is, you see two of the same aldehyde and base, and I forgot to put the water. That's not the only mistake on this page. I'll talk to you about that in a second or two. We have the alpha carbon, carbon bond to the carbonyl carbon, has acidic protons that you can remove with water and base. Sodium hydroxide is the base I'll use on a test. And attacks the carbonyl carbon, the other, forms a carbon-carbon single bond, and opens that up to a alcohol. And here, if we look at E, alpha carbon attacks the other carbonyl carbon. You remove one hydrogen from here, because remember, there's only 4 bonds to carbon, and this opens the second carbon, carbonyl group, up to an alcohol. That's how you get it. All right. Everybody look at the structure in F. This bottom part here has 2 extra CH2s. I'm sorry. It should be CH2 right here bonded to the CH. These CH2s, this one shouldn't be there. So I apologize, but that's the mistake I made, and please correct it. Any questions? Going once, going twice. Don't forget, this Thursday at 4 to 10 after 4, I'll send out an email with the password for test 2. You'll have until Friday, 10 a.m. to take it and upload it as a single PDF file to D2L. All right, we were talking about aldehydes and ketones. And I just give you the reaction of carboxylic acid with baking powder. Remember, there's a carbon there. This is sodium bicarbonate. It's one of the few problems I'll ask. Give all the reaction products. And I showed you get the carboxylate anion, water, and CO2. And this tells you it's given off as a gas. That's what the arrow up means, given off as a gas. And if you remember, time for Dr. White to bring back a fond memory. I just did. I talked about the little rocket ship with the candy in there that was awful, beyond awful. And you dump it out in a garbage can then, but you had a little rocket ship. My father showed me how you could take the cap off, put some baking powder and vinegar in there, and put the cap back on, hold it, and it builds up pressure from the carbon dioxide, and the cap goes, or the tube goes boom, and you just had a launch. And to a 5-year-old, that was the coolest thing in the world. In fact, we got time. Oh, we got time. That's not what I want. I'll be with you in about an hour. No, I'm just kidding.
It's time to help people customize and save with Liberty Mutual.
Okay, take number 3. This time, we've got a mixture of 1 cup vinegar to 1 cup warm water in a 2-litre drinks bottle with our launchpad system here. This time we're putting the baking soda inside a pop sock that's made out of tykes.
Everybody see that on YouTube?
The vinegar can get inside the pop sock more easily, and it won't get wedged in the end of the bottle when it's about to go off, which should mean the gas gets out more easily. Here we go then. So cut a little hole in the pop sock there. We're drying out. We should be able to reuse this actually. Very gently.
Do not try this at home.
We're going to feed our bicarb in the pop sock through the gap. Once we've got a bit in, we should just be able to gently dip it in through, push it on down. Right, now we've got the interesting bits. So put the bottom in the right place, ready to run back very quickly. Launch pads ready with the cork. Here we go, and oh, it actually suspends it. That's a nice feature. Ready? 3, 2, 1. Over we go. Bubbling away nicely. Pop sock looks like it's turned into a balloon. Oh, that's definitely a better delivery method. Look at it go. Oh, that's very frothy. That's very frothy. Whoa! Oh, success!
It's the pop sock.
Right, pop sock.
And for something safer to do in your kitchen. And vinegar, baking powder, blast off. And those bubbles have carbon dioxide in there. And that's the pressure that causes the rocket to go off on you saw. And when I was a kid, the same thing. I hope you all enjoyed that. I did. Organic chemistry is to be enjoyed and have fun with. And I do. All right, so we did that. Let's move on. I talked about carboxylate salts, like a preservative in pop, also in bakery goods. I'll talk about a special carboxylate salt or anion, which is our bar soap later on. All right, how do you make an alcohol? How do you make a carboxylic acid? You take a primary alcohol, switches on, and you oxidize it, you get a carboxylic acid. Now, if you've paid attention, I had for test number 2, I have the following reaction. Now, how do you know what you get? By the oxidizing agent and also reaction conditions. I've done both on a same primary alcohol, and you can control it. For test 2, you'll do this. For test 3, you'll do that. On the final, I'll accept either one. Well, let's look at oxidation of a primary alcohol. Again, remember, this is test 3 material, which is coming up pretty quickly. It's July. You're going to hate Thursdays because every Thursday we have a test. All right, general reaction. Primary alcohol oxidizes to a carboxylic acid. And let's do one. And what do we have here? Carbon-carbon hydroxy, and primary alcohol. And we're oxidizing it. That's what bracket O close bracket means. And the carbon with the hydroxyl group will now be carbon double bonded to oxygen, also hydroxyl group, and you'll get your carboxylic acid. What's our 2 carbons? Then I'll have my carbonyl group and hydroxyl. And you can't have a primary alcohol in a ring, so that's that. And why don't you do the following? Give the organic product or products their following reaction. I think just about everybody's done. I'll give you a little more time. This is a bad thing about teaching online with everybody with their camera off. I can see people's faces face to face when they're done. All right, I think everybody's done. What's different here? Ooh, oxygen with a hydrogen on a carbon. We're oxidizing it, so we have a primary alcohol. and we oxidize it with the right oxidizing agent, we will take it to a carboxylic acid. What's my R group? This. So I'll have it. It will attach to this carbon, carbonyl, hydroxyl group, and I know there are 4 bonds to carbon. Oh, that was fun. Let's do more. On test number 3, there'll be some synthesis problems. And there's one for you. What would you oxidize to make that molecule? And don't forget, I know 2 of you already have, to put up your thumbs up emoji. I still like my word, symbole. When you're done, I think we're all done. Let's give another couple seconds to everybody to finish up. All right, what's different here? Ooh, hydroxyl group and a carbonyl, a carbon double bond oxygen, it's the same carbon, and carbon's on there, and that's a carboxylic acid. And I'll call this my R group. And what do you oxidize to make that? A primary alcohol. So the carbon with the double bond will be the carbon to oxygen carbon with the hydroxyl group. So I'll have my R groups, 3 carbons. And then this carbon will have the hydroxyl group. If you notice, I have 1, 2, 3, 4. I end up with 1, 2, 3, 4. I got, oh, let's do one more. There you go, one more, because these are fun. All right, I think everybody's done. What do we have different here? Oh, hydroxyl group on a carbon. We're oxidizing primary alcohol. Oxidizing it to a carboxylic acid. And here, what's our methyl? And this is a carboxylic acid. And what's its common name? Acetic acid. Now, I have a question for you. Does anybody know what company in the United States is the greatest consumer, or you can say purchaser, of ethanol? You know, stuff you find in vodka and all that. You know which company buys the greatest amount of ethanol? Anybody have any guesses? Not even one guess? Well, I'll tell you. No, it's not someone like a company that makes hard spirits or anything like that. It's Heinz. Heinz? Why? Because they take the alcohol, ethanol, and oxidize it to acetic acid. And if you add water to acetic acid, you get vinegar. And Heinz sells vinegar, but they also use it in their ketchup, their mustard, and their pickles. So next time you look in your refrigerator, if you have mustard, ketchup, or pickles from Heinz or relish, you know, the stuff in Chicago that glows in the dark, I love that green stuff. I have a couple of jars backup emergency in my house. But anyways, they use that to make vinegar. Now, for many years, decades, they would do this chemically. In the last, I don't know, I'm guessing now 10 years or maybe a little longer, they found they could create a microbe, and now I'm way beyond my level of expertise, that eats the ethanol and converts it into acetic acid. So they do it biochemically now as opposed to chemically. Now, there's another thing about that reaction. Wine lovers hate that reaction. Why? Well, let's take a look. Ethanol, what an oxidizing agent, and air can be over a long, long time. Air will do this. Now, how many of you have ever tasted wine and it tastes like vinegar? Most French wines taste the same to me, but I don't like French wines. I have good German wines. But anyways, why does it taste like vinegar if it's gone bad? Because with time, the ethanol is oxidized to acetic acid, and the wine, which has water in it, acetic acid and water, vinegar. Quick story. Do I have time? Yep. I better be real quick. I'll wait until after the break. I don't want to run into your break. So let's take a 5-minute break. I'll see you in 5. I'll see you at 2:50. Sorry about that. I stuck my head out my door to get the mail. Boy, it's hot out there. Dr. White is not a summer person. I fall, spring, even winter, summer, no, you can take it. It's too hot out there. But anyways, I got my mail and I'm still on COVID-19 protocol, which means after I bring my mail in, put it in a safe place, sit for a couple of days, I look at it real quick. I wash my hands to make sure there wasn't anything on the paper, even though after a couple of days, but still, I'm playing it safe, especially with the Delta variant floating around now. All right, now, right before break, I didn't do this. Time to come back. Everybody back? Thank you. All right, now I was showing you this reaction. If you take ethanol with time, it oxidizes acetic acid. If you have water, it's vinegar. And that's how Heinz makes, well, they do it differently now, but for a while made vinegar this way for a long, long time. And this can happen very slowly in a wine bottle, which when wine goes bad, it tastes like vinegar because there is vinegar in there. The ethanol in the wine, the alcohol, with time, many, many years, becomes acetic acid because oxygen is an oxidizing agent. Now, I didn't want to do it before the break because I was going to rush myself. Back when I was in college, I was in a fraternity, Alpha Epsilon Pi. One of our fraternity brothers, this was still a new field, got into computer programming. And he was good, still is. And by the time we all graduated, we did pretty good. And by the early 80s, he had first worked for a huge bank programming. Then he decided, wow, I can make more money on my own. He started working for banks, doing programming for banks in the Bahamas and places where people hide money. He wasn't doing anything illegal, but they paid real good. And he could do it from his home in Chicago, or actually condo. Well, this fraternity brother loved wine. He was a wine connoisseur, and he had big bucks to be one. And he was in a somewhat not that large condo. This is in his dining room. Had this huge wall covered with a wine rack. Well, it only had a limited amount of wine. I think about 200 or something bottles, give or take a few. And he liked collecting expensive wine. We're talking back then, $200 to $400 a bottle. Figure now that would be double or triple the price per bottle. Every once in a while, he'd call some people like me, say, come on over this Saturday evening. Why? Well, we're having a wine tasting party I'm giving because I get rid of some of the bottles of wine because I want to collect some more. Every once in a while, it was rare. He'd open one up, we'd taste it. Oh, vinegar. And he'd get upset. Oh, it went bad. You know how much I paid for that bottle? And we laugh because here he had a wall of bottles that were all very expensive. But that's the story from Dr. White about oxidation of ethanol in a wine bottle. And that's one way to synthesize. Remember, synthesize is a fancy word for meaning make a carboxylic acid. Now, another way is if you oxidize an aldehyde. And here, oxidize an aldehyde and similar to a primary alcohol. Now here you replace the H with an OH and you get a carboxylic acid. And if you take any aldehyde, this will do that. And no, I'm not an aldehyde. I clicked on the wrong thing. Let's get to my whiteboard. If we look at the following, if we oxidize this, what do we get? Well, what's this? Hold on, I gotta clean this up. That's better. What's different? Carbon double bond to oxygen, hydrogen on that carbon, and carbons, aldehyde. And when you oxidize it, what do you get? A carboxylic acid. And this reaction I did also in grad school to make certain compounds I needed. So if we look at here, this is our R group attached to this carbon, which is this carbon. So it'll still be attached to that carbon. You'll still have the carbonyl, and this is replaced with the hydroxyl group. And there are 4 bonds to carbon, so I can put in my hydrogens. And why don't you do the following? Give the organic product or products 3 points each. Remember, this material won't be on test 2 this Thursday, but next Thursday is test 3. It's summer, it's July, it's test on Thursday. Turns out I've taught this class a number of times this summer, and that works out real good. All right, let's almost do it. Anybody need more time? They should have an emoji. Stop. Well, they don't, but you can always send me a private chat. All right, what's different in this molecule? Ooh, oxygen, double bond to carbon, has a hydrogen on it and carbons here. I'll call R, aldehyde. And if I oxidize it, what do I get? A carboxylic acid. And here, what's our R group? All of this. 1, 2, 3, 4, 5, plus this is 6. You don't break carbon-carbon single bonds. Here's my R group. This carbon right here will now still have the carbonyl, carbon double bond, but now instead of a hydrogen, we'll have this hydroxyl group, and there are 4 bonds to carbon. So I can put in my hydrogens. Excuse me. I just burped. Must be a carboxylic acid do that to me. Not really. All right. What would be the molecule you oxidize to make that molecule at the head of the arrow, your product? right, I think everybody's done. Let's take a look at this. What's different here in the product? And the answer is oxygens. Carbon, double bond to oxygen, has same carbon, has a hydroxyl group, and on that carbon is carbons. And that's a carboxylic acid. Here's my R group. When you oxidize it, what do you start with? Now, this one, there's two answers, but for this problem, I was looking for the aldehyde. If you put down the primary alcohol, I would have to accept it on a test. And therefore, what's R? My isopropyl, I have this carbon right here, aldehyde, and there you go. Oh, let's do one more. I keep on hitting my whiteboard when I don't want to. It's clumsy Tuesday. Doesn't it feel like a Monday? Now, oxidation reagents will not touch a benzene. And have fun. And when you're done, don't forget, give the thumbs up. All right, anyone need more time? You can always send a private chat message too, if you do. All right, let's take a look at this. What's different? Oh, I got a benzene ring, but that does not react with an oxidizing agent. But here I have, think of benzene as R group, carbonyl, hydrogen. And I'm reacting an aldehyde with oxidizing agent, and I'll get a carboxylic acid. What's my R group? The benzene ring. Carbonyl And now it's a carboxylic acid. This you should know for Thursday because it's on test. That's benzaldehyde. You don't have to know it now, but for test 3, this is benzoic acid. At room temperature, this is a liquid. At room temperature, this is a, I should say, white solid. And why am I telling you this? Well, if we had been at ECC doing the labs face to face, remember the lab where you smelled the chemicals? Benzaldehyde smelled like both maraschino cherries or Dr. Pepper and almonds. It's a liquid and it's in a bottle with a screw cap. And you also use the benzaldehyde for the ketones aldehydes lab. Don't forget that's due tomorrow. But if you looked at that cap, you'd see right around the threads of the cap here, when you take it off, a white solid. Where did that happen? Because the benzaldehyde is a liquid. Slightly colored liquid, but it's a liquid. Well, it turns out the air all around us and the air, oxygen in the air, when you pour it, sometimes there'll be some liquid that gets on the outer part of the threads of the bottle, and that's going to be exposed to the oxygen. And with time, benzaldehyde is oxidized to benzoic acid, which is that white solid. See, chemistry is happening all around you. Organic chemistry. All right, we're talking about how to make carboxylic acids. And the next one is really cool. I mean it, literally cool. And that's reacting a Grignard reagent with carbon dioxide, step-and-step acid or acid and water. I should correct that. And you get a carboxylic acid that's 1 carbon longer than the R group you started with. Now, why do I say this is cool? When in the lab, you use dry ice, which is a solid carbon dioxide. And you do this, you put some dry ice in this and ether, second step, add acid and water, and you make your carboxylic acid that's 1 carbon longer than the Grignard you started with. Now it's time for Dr. White to have some Dr. White fun. How does this happen? The following, the switch is off. Now, carbon dioxide really looks like this. And like I said, you get a carboxylic acid that's 1 carbon longer than the R group you get, and it comes from here. Well, doesn't this look like a ketone if I cover one side? And this attacks that, just like a ketone. Now with a ketone, it would open it up to a alcohol, but before you add acid and water, it looks like this. This will never be on a test. And you still have the carbonyl here that doesn't touch. Well, acid and water will convert this carboxylate anion into that carboxylic acid. And Dr. White just showed you a mechanism. This will never be on a test, but now you understand what's going on. Let's do a reaction. First of all, again, Grignard plus CO2. Remember, X can be chlorine, bromine, or iodine, those halogens. and you get a carboxylic acid that's 1 carbon longer than the R group we started with. This reaction I'll never put on a test as a synthesis problem. And what do we have here? We have magnesium halide, a Grignard reagent. X can be chlorine, bromine, or iodine. In this case, it's iodine plus CO2, second step acid plus water, and you get a Grignard. You get a carboxylic acid that's 1 carbon longer than the R group you started with. What's my R group? Right there. So I'll get this, then I'll write my carbonyl with the hydroxyl group. Notice I started 2 carbons here. I end up with 3 carbons because you add 1 more from the CO2. And that's how you do it. And here's one for you to have fun with. What would be the organic product or products? 3 points each. Enjoy. I'll give everybody time to finish, even though I know some of you have. Please be patient. All right, let's do this. Remember, look for what's different, what's not. Hydrogen and carbon should get your, magnesium chloride on a carbon. And that's a Grignard. X can be chlorine, which in our case it is, bromine, or iodine, plus carbon dioxide, second step acid, H plus is acid, and water. And what you get is a carboxylic acid that's 1 carbon longer than the R group you started with. And here's my R group, 3 carbons. I'll have 3 carbons. And then my carbonyl with the hydroxyl group. And notice I started with 3 here. I end up with 4 because I get the carbon from the CO2. Oh, let's do another one. And there's one for your fun and enjoyment on this Tuesday afternoon, even though I almost said Monday, because it feels like a Monday, because tonight I got to put my garbage out. We normally have Monday pickup, and that's an anchor in my brain what day of the week it is. And tomorrow we'll have pickup, which normally is Tuesday, but it's a Wednesday because yesterday was a holiday and we had no garbage pickup. I see one person done. Don't forget to give me a thumbs up when you're done. Or you can turn on your video and I can see that. I'm done, look. Get to work, Dr. White. All right, thank you. All right, what's different in the first molecule? Got a ring. That's just carbon and hydrogens. Carbon, ooh, halogen on a carbon. And I just blew this. I'm sorry. Dr. White messed up. Must be getting near the end of the day. Now I'll do it right. I'm sorry. I'll give you another one. You have a Grignard. X can be chlorine, it is bromine or iodine. And CO2, H plus, and water, you get a carboxylic acid that's one carbon longer than the R group you started with. And that is to right. That's my R group. I have that, CH2, and to the carbon with the Grignard, I'll put carbonyl OH. And that's how you do it. Let's do another one, see if I can get it right now. And I did, I got it right. I see one person done. Two. And I think everybody's done. All right, let's take a look at this. Now I got it right, finally. What's different? Carbon, 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 magnesium, iodide. It's a Grignard, where X can be chlorine, bromine, or iodine. I'm reacting with carbon dioxide, that's CO2. And second step, acid, catalyst, or acid and water. H plus means acid. And you get a carboxylic acid that's one carbon longer, which comes from the CO2 than the R group you started with. What's my R group? A big scary molecule unless you know what to look for. So I have 1, 2, 3, 4, plus my two methyls. Which carbon has the Grignard? That one. I'll add one more carbon, carbon double bond with the hydroxyl group, and I'll put in my hydrogens because I notice there are 4 bonds to carbon. And that's how you do it. Like I said, it's a cool reaction because in a lab, most of the time, you just take the Grignard, put it in a round bottom with ether. One of the things I haven't talked about this whole semester is all the chemistry I've ever done, most of organic chemistry is done in a solvent, like ether or other things, water, who knows, but in a solvent. Then you drop in some dry ice, let it go for a while. Then after a while, you add acid and water, second step. And that's a cool way, hint, cool, you can make carboxylic acids. And let's continue on. Oh no, hold on. I got computer brain freeze. Sorry about that. I've got so many things hooked up to this computer, even though it's a powerful one, it sometimes burps like that, and I got to close Word and open it up again. It's fine for a while. Because right now it's this computer, I have a tablet, my mouse, a webcam. I'm also on internet. I'm doing a lot of stuff, plus Word and a few other things. All right, let's get back to work. And we just talked about reaction of a Grignard reagent with carbon dioxide to synthesize to make carboxylic acids. Oh no! Guess what time it is? It's new functional group time. We've done everything we're going to do with carboxylic acids, just them alone. And now it's a new functional group time. And this new functional group is going to be quite exciting. It's going to smell and taste really good. I'm going to talk about a personal story, and then I'll get into things. You'd never think about that. They really did that? Yes, they did. So we're going to get into that. But before I do that, I was just looking at my notes here. I realized once again, I forgot to do something, but I looked in time. So before we go into that new functional group, how do I take this, take that back? There's something I want to talk about. Now, when I grade a test, if you're off by 1 carbon, I mark it wrong. And you might say, oh, come on, why are you being so picky? Well, it turns out 1 carbon can make a difference. There's a sort of sad story, it could have been a lot worse, that I need to talk about. And that is, how many of you are familiar with the product? Came out, I think, in 2007. So I guess some of you might be young. Oh, I shouldn't have said that. But anyways, it was called Aquadots. And Aquadots was made by an Australian company, you know, kangaroos and all that. And there they called it Binzi. When they brought it to the United States, they called it Aquadots. It was quite successful, very popular children's toy. And like I said, it was also called benzene. And they were these little spheres that you put in a tray. Can everybody see that right now on your screen? A tray, okay. And then after you constructed some shape or whatever, like a clown they look like they're making over here, you'd spray it and the dots would, the little spheres would stick together like glued together, and you could pick it up and you've got whatever you made. And it wasn't that expensive and it was a lot of fun. Then unfortunately, a lot of children were getting sick. What happened? Well, it turned out they tracked it down. Now, what you don't know, but I'll teach you is many chemical companies, when you have a product you're making a lot of and you don't have enough room in your company to make more because sales are booming, you go and get another company to make that for you and you pay them. I don't know how it got the name, but that's called toll producing. And I've worked for companies that had other companies make things, we call it toll produce something. In fact, part of my job for one company was we had two companies that were toll producing stuff for us. And I went down there and inspected everything to make sure it was done properly. Well, this Australian company went to China and found a company, chemical company in China, to make their product inexpensively. And plus they had the capacity, the equipment to make the amount this Australian company needed. What the Australian company didn't realize is this Chinese company, and I'm saying all Chinese companies are like this, but you got to watch out for some of them, said, we can make more money. Instead of using this chemical in their formulation, we'll use this cheaper one. And they did. And when they made that substitution, children started getting sick. Think about it, those little beads, what are they going to do? Pop them. And the Australian company had already figured that might happen, and it was safe. Yeah, they come out at the end, but anyways, they wouldn't cause any health hazards to children. I guess if you had a whole mouthful, you might choke, but you could swallow them just like little beads. So what did that Chinese company do? There was a chemical that was in the formulation called a plasticizer. And it was a diol. And a diol is two hydroxyl groups in the same molecule. And this would be 1,4-pentane diol. And I don't expect you, and this is not going to be on test ever, but it's an interesting thing why you have to be very careful making things. And this is a safe product. If it's consumed, it's not going to make anybody sick, but it's expensive. And the Chinese company, without telling the Australian company, said, oh, we can make more money if we substitute this for a cheaper chemical. And they did. And the cheaper chemical was this compound. 1,4-butanediol, which you can get a lot cheaper than the 1,4-pentanediol. And the only difference is a methyl group. And this should be CH2, sorry about that. But it turns out when this is oxidized, which can happen in your body, like your liver or other places, don't ask me how, one of the hydroxyl groups can be oxidized to carboxylic acid. And this is also known, this new hydroxy acid, as the date rape drug that has harmful effects, especially on children. And it can be very serious. And a couple kids almost died. And they tracked it down to the Chinese company doing an unauthorized change in raw materials, the materials you use to make that. So 1-methyl group, when this is oxidized, it's safe. This is the date rape drug, which has serious internal effects on people's bodies, especially children. So 1 carbon can make a difference. And now I remembered that story. I should have done it earlier when we were doing oxidizing alcohols to carboxylic acids. That's a true story. Let's see something. It was a company, here's their name in China. And it should have been 1,5-pentane diol. And they have 1,4, it should have been 1,5. And they used the 1,4. And that gamma hydroxy butyric acid, which is what I just drew, is toxic. And that's the problems. And it's quite amazing how things like that, you have to be very careful. And that reminds me, do I have time? Yeah, I have time for a quick story. When I was at one company, AXO, my job was in charge of all product and process development for this one big part of their nitrogen derivatives. We'll get to that in another chapter. But one day I got a call from the plant manager at one of our plants who said, this product we've been making for decades, we put the raw materials together and it shot up about 100 yards into the sky with foam. I said, what? And what? It shouldn't happen. So I sent someone over, a plant was right next door in our research building. And I said, take samples of the raw materials. They brought it back to the lab and I watched and they mixed together, did a reaction, and it foamed up and shot right up in the hood and made a mess, which I had to go on the manager. I walked away, but I thanked him for cleaning up. And I figured, all right, how do I solve this? And the first thing I knew was at another plant of ours, we made one of the raw materials. And I called the plant manager and I said, in this product, did you change the procedure in any way? And he's sort of hemming and hawing. I said, come on, this is important. He said, oh yeah, we made this change. Instead of doing it this way, we're doing it that way. You can't do those changes. Well, it turned out that change left something in there that caused that problem. I said, go back to the old way, and they did. They shipped us some before the other plant made it. I had some samples and we made that and it didn't foam anymore. So changes and things you should never do. One of the rules I learned early on in the chemical industry, you never experiment on a plant scale. Never. It's tempting, but you never experiment on a plant scale. What that means is if you want to change things, you send it back to the lab, you change it and see if it makes a difference. You don't in a chemical plant say, oh, I'll change this. Nobody will know the difference. In fact, another story I'll tell you about, same thing happened. The plant manager made a minor change he thought was a major one and almost cost the company $60 million. Yep, 60 mil. And I had to get in there, boy, it took me about 3 weeks to find out because he didn't tell me he made a change. And it was so minor, but it was so major. And that was the problem. You know something? Tomorrow we'll have a lab but we'll also go into that new functional group that smells good, tastes good. And I'll tell you a couple stories I think I'll get to. And we'll also have our lab. Don't forget, Thursday, test number 2. I've gone through the problem set for ketones and aldehyde, and we finished this last week. So you had plenty of time, and you still do the practice problems. Remember, like test 1, the practice problems are called that for a reason. Hint, hint, wink, wink, say no more. That comes from Monty Python. But with that, I'm going to say, gang gesund, be healthy. I'll see you tomorrow. Don't forget, hand in your lab, and bye now.